their journeys going to work, to university, fine. The first approach will be ask people, and you know that, how to ask people to the proper questions. And the other thing will be use technology. Use technology to make a passive measurement and to track people. The first one also implies technology. We have made more than 35,000 interviews in Spain. We have been working since year 2000. And to ask people, we use a tablet PC. With, it's a digital computer. It's with a touch screen. The people is able to draw their journeys from how they go from home to work, to the university, or to shopping malls. And if, for example, they take the car or they take the bus, the train, the map changes and suddenly, there's the train map and the digital map. So with this technology, we have been able to make so many interviews, and we discover that this is very good and quite accurate for medium and small cities. Also, it's good for regular journeys because you know perfectly how to go to your work. You can go with your eyes closed. So it's not a problem on memory. So for regular journeys, it's quite accurate. But it's not so accurate, it's not so good to measure these journeys on big cities because there are so many possibilities. The journey is so big and has so many different ways to go to some places that we have more problems. Basically because there are many options. Most of you will go in the morning, you will go very fast to your work because you don't have time. But when you come back, you have many alternatives. You will go maybe to buy something, or you will go with your friends, or if the city gets bigger, if there are so many leisure options, the journey path, it gets so many different alternatives that it's very difficult to track them on a tablet PC. And of course, there is the memory recall. Things beyond 1 week or several days, you get the problem of, well, I can't remember really how I went to 2 weeks ago to some place. So tablet PC is very good, very accurate for regular journeys, but it has some trouble on other areas. So the next question obviously is, well, we can track people in a passive way. How can we do it? And I'm sure that all you will think, use a GPS. That's perfect, sounds wonderful. Most of you don't know what GPS stands for. GPS is good points, sometimes. Only sometimes. And I'm sure that most of you have used GPS before. And it's not a proper solution for out of home. Understand me, or bear with me what I'm going to explain now. It's not a proper solution, so it's like a surprise. Wow, what this guy from Spain is telling me that the GPS doesn't work. I have one in my car. Well, what you have in your car is a navigational device. It's an integrated GPS integrated in your car. We are not talking about that because this device is connected to a battery. It can make so many measures in only 1 minute. It really knows that you are in a car, so it's cheating you. It knows that you have to be on the street, that you have to be on the road. Also, it has a bigger antenna than any normal GPS or any normal mobile phone. And it's connected to the steering wheel or to the engine or has a accelerometer. So you can check if you have integrated navigation on your car, you can check that maybe you're going underground on the parking or in a tunnel, and it will keep you saying how you turn and how you move. This is impossible. If the device doesn't see the sky, it won't work. So we are not talking about that. And in fact, there are also many problems on the GPS. There's a urban canyons problem, time to first fix. When we say the cold start, when you start up the GPS, it takes many time to locate it. And there are mirrors and also there's a lot of trouble with that. And it's really, you have to understand that it's quite different if we're talking about accuracy or we are talking about reliability. I mean, accuracy, of course, a GPS gives you a very accurate measure. This means so many zeros. It looks, wow, that's a very good measure. But we don't need that. Of course, it will be wonderful But what we need is reliability. We need that the GPS has to be able to be measured along the whole complete journey of our interviewer. For example, in Spain, the biggest and the most important streets in Spain, where there is a lot of advertising, of course, where it's a lot of traffic, the people who carries the GPS, with the test that we have done, will lose the signal if they are walking near the buildings. Do you imagine telling to use the code to clear channel, yes, this is quite accurate, but look, the best places, we don't measure the best places because there is some trouble with the device. It won't be useful, isn't it? So don't confuse accuracy with reliability, a complex word in English. Reliability. We want a consistent measurement all over time. We want to make the same circle one day, other day, and a complete circle. We don't want holes or gaps on the information. So that's what we are looking for. We need a solution. We need what we call a GPS, which stands for Assisted GPS. Well, what is this about? Let me explain you how the GPS and regular GPS works. Normally, a satellite sends the signal to the GPS. This signal really is a time data, a clock data. It's the time, so with the several signals you can make a triangulation. Well, really, it's not like this. It's not only the time. What we are sending from the satellite to the device is the orbits, the ephemeris. It's the information where it's going to be the satellite, where it's now, and where it's going to be in the next minutes, in the next 5 minutes, in the next hour. So the device is able to look each time where to find the satellite. So we send the orbits, but this has to be done at least with 4 satellites to make the first position. So you have to wait. You have probably with your own GPS in the car or in the booth or wherever. You will know that when you start up your GPS, it takes time. It takes a lot of time, even to make the first position, because it has to receive a huge amount of data from the satellites, and it gets worse if you are moving. So if you are in a parking and you get out and you start moving, it will take much time. So, what is the solution? We need help. We need what we call an auxiliary channel. We don't need to receive the information directly through the satellite. If we use another auxiliary channel, another way to receive this information, it will help us. So, imagine that when this GPS gets lost, and for example, it's here, we don't see the satellites because if we are on a roof or on an underground or on a parking, we don't receive the signal. The trick, the cheat, is, well, we add a mobile phone. With the mobile phone permanently connected, we can use a GPRS connection, because the mobile phone is permanently connected to a cell tower, to an antenna. By the way, the antenna is perfectly located. We know the coordinates, the longitude, latitude of this antenna, and we know perfectly what are the satellites that this device or this mobile phone should receive. So through GPRS, we are able to connect to the antenna and then send information to the server. Our server will send back, our assisted server will send back the information of the orbits, of the time, and everything that the device needs to locate. So, and this happens much quicker than using the satellite, from the signal of the satellite. So even now, if it's lost, now the device connects to the server through GPRS, it gets back the information, and one thing that's good is it gets properly processed, ready to operate. So this means that at the next second, when I get out, the device would perfectly locate where are the satellites instantly. So the first time to fix, it will be quite faster. So we get some advantages from this. The time to first fix is much faster. We need a very low satellite signal. Instead of receiving 100% information from the satellite, we only need 1%, because the rest of the information is through this auxiliary channel. So also we need less CPU power, because all the information is already